The behavioral consequences of intraocular scatter are often severe and central to many common problems, such as driving accidents. This study represents a novel method for measuring the effects of scatter on visual recognition. The main advantage of this methodology is its high degree of ecological validity, while using relatively simple optics. Cataract is the leading cause of blindness in the world. Prior to overt disease, the lens scatters light and degrades vision for decades. Proper measurement could motivate more timely treatment.
Working on an optical table, install a 1000 watt xenon arc lamp with the associated power supply at the posterior end of the bench. Install the first lens at a position that collimates the light from the source and introduce an optical element to remove heat within the optics generated by the intense light source. Introduce the next lens within the optical system to focus light to a small point on the 100mm circular neutral density filter, which attenuates light over a linear range of about 2 log units of optical density. Determine the nominal position of the filter using a digital readout coupled to a potentiometer. Install a diffuser behind the neutral density filter. Use a calibrated radiometer to determine the actual amount of light transmitted that corresponds to the circular filter's position and to periodically confirm that the overall energy within the system remains constant over the course of the experiment. Use a mechanical shutter or a blocking filter and holder to occlude the stimulus between trials. Add the next lens to the system, a collimating lens, placed such that light expands to match the diameter of each letter aperture, fully illuminating the optotype. Construct the letter